welcome back. So I've just started doing some private tutoring of high school mathematics students, and I am loving it, partly because I'm learning stage 6 concepts, so integration, calculus, and things that are considerably more difficult than working out the area of a quadrilateral. And so the problems that I'm solving are way below the kind of the level of difficulty that I'm attempting in my own degree. And it's partly because every student that I've got is really different. No two students learn in the same way. They don't communicate in the same way. Their knowledge base is not in the same place as the other person. And so I am learning so much. I want to share one experience that I had. One of the students, lovely kid, good communicator. We were working out what 7 and 8 was or something like that. And they got out a calculator. I'm like, what are you doing? She's like, oh, I'm adding up 7 and 8. It just did my brain in. And she's like, oh no, our teacher tells us to do this stuff all the time. I'm like, okay, right. Who knows what the teacher says and doesn't say, and I don't want to go down that road because you don't know, right? But I'm like, this is not acceptable, this is not cool. And I've been speaking to university lecturers and they're like, Graham, that's really common. And I'm convinced that it is. When I was in about year 9, I had a teacher whose name I think was Mr. Murray, and I think I had him for 2 years, maybe consecutive, maybe not, I don't quite recall. But what I do remember is he was an absolute martinet about getting us to put down our calculators and work out not only things of that kind of difficulty, but multiplication, and multiplication to at least, like 2 places. And I bless the memory of his name, because even today, I can do problems in my head that most people would reach for a calculator for. So I'm so grateful, and I just think if I don't do something to at least move the line for these kinds of kids, I might regret it, It doesn't matter if they don't learn their 20 times tables. I had a friend in school who did that. But let's get them a little further along the way. How would they go about solving this problem? It's not immediately obvious that it's a 5-based problem, although there is a 5, but it's like, 5 times a what, It's definitely not a 10s-based problem. Or is it? Because with one simple step, if you halve the 4, and you take that 2 and you double the 35, which you can do because multiplication is commutative, well, now all of a sudden you've got a problem that looks a lot more manageable. 2 times 70, well, that's not so hard, because one of those numbers is got a 0 at the end. It's a 10 problem. So now you're talking about 2 times 7 times 10. Well, let's just put the 10 to the side for a moment. What's 2 times 7? There'll be kids who don't know that because they don't know their 7 times tables, but they could step count, right? 2, 4, 6, 8, 10, 12, 14 times 10 is 140. This problem became so much more wrangleable with just one step. Take the 2, swap it across the other guy. So what I'm thinking is that in even year 9, year 10, if we can reduce some mathematical problems to strategies that kids can deal with, so it's 2-based or it's 5-based or it's 10-based, they're going to find that much more manageable. I hope that's been helpful, and if you have fan mail for Louis, don't forget to leave it in the comment.